Hi, Jake. My name is Caitlin. I'm a friend of your mom's, and she mentioned that you have a summer math packet that you have to work on. I offered to help because I've been teaching 7th and 8th grade math for on and off for about 15 years now. So I'd love to go over this with you. I'm sure you probably know a lot of what's already in the packet and that this is probably just going to be a repeat or a reminder, maybe a refresh or whatever. But what I do like about doing a refresh is that I am going to, like I said, I've been doing this for 15 years. So I'm going to be showing you some things that I've picked up over those years. I'm going to be honest with you, I'm lazy. I'm going to show you the easiest way to do things because after 15 years, I have figured out how to do things the fastest and the most efficient way possible. So that is my job today. Okay, so this is the packet your mom sent me. So we're gonna work on this. I'm gonna start with that first page, which looks like it's fractions. Now, you are probably groaning, and like every other kid that I know, you're like, no fractions. Don't wanna do fractions. I'm never gonna use this in life. I hate fractions. I hate fractions. That's what I hear from all my kids. But the unfortunate part of this is that you will need fractions to succeed in math from now until you're up any upper division math class. So like through calculus kind of a thing, okay? So if you're not understanding fractions now, we really got to make sure that you do. Otherwise, you're just going to struggle when you hit algebra next year. And I would hate to see that happen. So what I'm going to show you is a bunch of refresh on these fractions. And just let me know if this is helpful or if you have any questions. We can go from there. So starting on page 2, I forget that I have this here. I'm not technologically savvy. So on page 2 here, we're going to start with these fractions up top. So looking at number 1, we have 7/10 plus 1/10. 7/10 plus 1/10. All right, so this is good straight off the bat. First things first, I actually think multiplication and division of fractions is a lot easier than addition and subtraction. Unfortunately, because the way the packet's aligned, we're going to start with addition and subtraction. When we do addition and subtraction, we need to find a common denominator. Remember, this is your numerator, this is your denominator down below. In this case, we have a common denominator. So right off the bat, we can do this. So we carry our denominator over. At the top, we do 7 plus 1, which gives us 8. Now, if you give a fraction as an answer and it is not in the most reduced form, let me just tell you, I don't even know your teacher. I'm going to tell you your teacher is going to mark it wrong. You must reduce your fractions, okay? That applies again from now until forever. There are several different ways to reduce fractions, and we're going to talk about some rules of divisibility. I'm going to kind of throw those in there as we go along. But for right now, what we can do, the first rule of divisibility that we're actually going to talk about is 2. We know something is divisible by 2 if it's an even number, right? If it ends in an even number. So we know that this is going to be divisible by 2, divisible by 2. Now, some people think when you are solving for, or you're reducing your fractions, you should divide by the greatest common denominator, or greatest common factor. I couldn't think there for a second. But in all honesty, as long as you're dividing by something, for the most part, I think it's like 2, 3, and 5, you'll be fine. So we're going to divide both the top and bottom by 2, because if I do it on the top, I have to do it on the bottom, the exact same thing. We get 4 over 5. So that's your first answer. Again, probably this is all repeat for you, but it helps to have somebody along for the ride, I would imagine. That way you don't feel like you're alone doing this packet where you're struggling and you're like, that's ridiculous. Okay. So same thing here, we're going to keep the same denominator. 5 minus 1 is going to give us 4. Again, we can cut these guys in half, and when I say cut in half, I mean divide by 2, because they're both even, right? So we get 2 over 3. 2 over 3. All right, so let's look at this next one where we have, and I'm actually going to erase. There's a couple different ways of doing these. So I'm going to show you 2 different ways for number 3. 3 1/4 plus 1 3/4. Okay, looking at this, you may have been shown to do this. You want to find, these are in mixed number form, and we want to go to improper fraction, right? So we do 4 times 3 is 12, plus 1 is 13. 13 over 4. Plus, and we do 4 times 1 is 4, plus 3 is 7. So that will give us 20 over 4. 20 over 4. Now, of course, we want to reduce, and we know that 20, and a fraction is just a fancy way of saying divide, right? So 20 divided by 4, make sure you know your multiplication tables, because that's going to give us 5. If you don't know your multiplication tables, or you have any questions, another good thing to have in front of you is a 20 by 20 multiplication chart. Not just the 12 by 12 or 10 by 10 that you see, but a 20 by 20 is really helpful. Okay, so like I said, there are 2 different ways of doing this. Another way of doing these guys right here is I like to put them vertically like this. Oop. 1 3/4 like this. And I deal with this guy right here, my whole numbers, I get 4. And right here I get 1/4 plus 3/4. That's going to give us 4/4. But when we write mixed numbers like this, what we're actually saying is we're adding those two things together. So like up here it's 3 and means add usually. 3 and 1/4, so it's 3 plus 1/4. 4 plus 4/4, except we don't write 4/4, right? We write, which equals 4 plus, because 4/4 equals 1. Do that, we get 5. So hopefully that makes a little bit more sense. Okay, so then let's look at the next one. And that definitely will make sense for this next guy. This is number 5. 1 2/5 plus 6 8/15. Now, so we're getting into like 15 times 6 plus 8. Blah, I can't be bothered to do any of that. Let's just deal with that fraction bit first, okay? That fraction bit first. We need a common denominator here for these guys. Our least common denominator is going to be 15 because 5 goes into 15, okay? In order to get 15 on the bottom here, I need to multiply by 3. If I do that on the bottom, I also must do it to the top, okay? So let's rewrite this guy now. We have 2 times 3 is 6 over 15 plus 6 8/15. Again, we can add up our whole numbers here, and I don't know why it gets fuzzy like that, I'm sorry. We add up our whole numbers, we get 7, because 1 plus 6 is 7. 6 plus 8, we get 14 out of 15. There you go. We didn't have to convert it into improper fractions, from mixed numbers to improper fractions. I think this way is a lot easier. You just have to be careful because sometimes you're going to get over your denominator here and you got to add your additional whole ones over here. We'll get to those as we go along. Okay, so for number 6, 5 1/9 minus 2 5/6. 5 1/9 minus, okay, so we have to find a common denominator between 9 and 6. Now, most of the time you can multiply those two things together and get a denominator. In this case, 9 times 6 would be 54. However, I think it's a lot easier if you find the least common denominator or the greatest common greatest common factor. So let's look at, I'm sorry, I lost my train of thought. I have ADD, so I apologize. I'm all over the place. 6 and 9. So what we're going to do is I'm going to highlight 6 so you can see this here, all the way up to that 54, and then 9 up to that 54. All right, so you see that we have all of our 6s, our multiples of 6, and we have all of our multiples of 9, right? Looking at these, it looks like actually 18, they have 18 in common. Do you see that? So that one's going to be smaller than 54. This is a better decision for us because then we don't have to reduce the fraction at the end. Oh, we may still have to reduce the fraction, but it won't be as bad. So let's go back. We know that our common denominator is going to be 18. So right here, I'm going to need to multiply that by 2. And again, what I do on the bottom, got to do that on the top. Here, I'm going to multiply this by 3 times 3. Move my stuff out of the way here. All right. So what I have now is 5 2/18 minus 2 15/18. All right, so I could do the 5 minus 3, but let's deal with this fraction bit first. The deal with the fraction, if I did 2 minus 15, I would get a negative number, and we can't have that for this kind of work. So what we need to do is borrow from the whole amount, and here's how, from the whole side. Here's how you do this. We borrow one whole one, so that makes this 4. Whatever is on the bottom here, you're going to add to the top here. So let's rewrite that now. We have 4 20 over 18, making this little bit an improper fraction, right? Minus 2 15 over 18. All right, so we've got our 18 here. We know that because we have our common denominator. 20 minus 15 gives us 5. 4 minus 2 is 2. 5 and 18. 2 goes into 18, 3 goes into 18, but neither of those numbers go into 5. So that's as reduced as it's going to be. Reduced as it's going to be. So that's a nifty little trick for subtracting when you have to borrow, okay? And I saw that there were some other fraction pages in this packet. So hopefully this information will come in handy. Okay, so let's look at number 7 here. We have 1/3 times 4 fifths. 1/3 times 4 fifths. Okay, when we're multiplying fractions, like I said, it's a lot easier than addition because we can multiply straight across the top, straight across the bottom. We don't have to find this common denominator nonsense. Oh, the other thing I wanted to say is that now that you're going to be in Math 8, this is probably going to go away as far as multiplication goes. You may see a dot, you may see parentheses, things like that, but you'll probably see less and less of that x because it gets confused for a variable. But for right now, I'll leave that there. Okay, so like I said, we multiply straight across the top 4, straight across the bottom 15. That can't be reduced any further. And when we get to some that can be reduced further, we can cross cancel on some of these problems. And when we get to that, I'll explain that a little bit more. But because we couldn't cross cancel anything here, this is 4/15. That's your answer. All right, so for 8, we have 12 times 3/4. This is one where we'll be able to cross cancel. Now, anything can be turned into a fraction by putting it over 1, all right? So I'm gonna rewrite this, guys. 12/1 times 3/4. Now, you don't have to write all this down, but I wanna show you why this works. So 12 times 3 over 1 times 4, right? That's what we're going to be doing. Now I could do that and I'd get 12 times 3 is 36/4. Again, I'm lazy. I'm going to find the easiest way to do something. But let's talk about that 12. We can break that down into 6 and 2. That doesn't really help us too much, but we can do 3 and 4, and that will help us. 12 can be written as 3 times 4, and then we've got that other 3 here, so I'm going to bring that over. And then on the bottom, we have 1 times 4. Well, 1 we can just cancel out, right? Anything times 1 is itself, so that's just get that out of the way. But these 4s, if you have something on the bottom and the top, like this, in this case, you can cancel these guys out, okay? You can't do that when there's an addition involved, and we'll get to that, but if there's multiplication involved, bam, you can cancel those out. So all we have left on top is 3 times 3, which we know is 9. On the bottom, we have a 1 left, but we don't need to write that. You don't need to do 9/1. I'm lazy. Again, I'm going to do I want to write as little as possible. And that's kind of the way I'm going to be showing you these guys. All right, so let's look at number 9. Number 9. And after I go through this page, if you think you can do any of these, start by pause the video, work on them, and then come back and make sure you got them right. So 5 3/4 times 10 2/3. All right, unfortunately when we're multiplying and dividing these guys, we have to turn them into improper fractions. So we're gonna do that again. 4 times 5 is 20, plus 3 is 23. Keep that 4 that we had right here, times 3 times 10 is 30, plus 2 is 32, over 3, 32/3. Now I can break these guys down. That 32, let's do a little bit of side work here. 32, we can break that down into 2 times 16, right? And then 16, we know, is 4 times 4. All right, let's just stick with that for right now. We could break down 4 times 4 further, and we'd have a bunch of 2's, but let's just try this. 23 is a prime number, so we can't break that down any further. So what I have is 23 times, and instead of 32, I'm going to write 2 times 4 times 4, because 4 times 4 is 16, times 2 is 32. It's 4 times 4 times 2, all over 4 times 3. Got that? All right, this 4 and this 4 can cancel out, okay? So on the top, I'm going to have 23 times, and 4 times 2 is 8, so let's just say that. Let's make sure I give you enough room here. 23 times 8, we get 8 times 3 is 24. 8 times 2 is 16, plus 2 more is 18. So we get 184 over 3. Now let me show you a trick. I want to know if 3 goes into 184. I can't really, without using a calculator, right? I could sit here and try and divide it, but again, I'm lazy. I'm going to show you the easiest way to do something. What you can do is this. You take 1 plus 8 plus 4. 1 plus 8 is 9, plus 4 is 13. Does 3 go into 13? No. So 3 is not going to go into this number. That's my favorite little trick. So that's how you tell if something's divisible by 3. All right. So this is our answer here. Now, with that said, once you're in algebra, you can leave things in improper fractions. I don't know if your teacher's going to want to convert it back into a mixed number. If that's the case, we're going to have to do some math here. So we're going to have to do, this 184 is on top of the table, so it's going to go under the table here. 3, right? So 3 goes into 18 without going over 6 times. 6 times 3 is 18. We subtract, we bring down, and when we subtract, we bring down 4. 3 goes into 4 one time. And if you remember this bit, if a decimal is not shown in a number, it's at the end. So it's right there. So is this guy. 3 goes into 4 one time, and then 1 times 3 is 3. We subtract 1, and we bring down an extra 0. 3 goes into 10 3 times without going over. We get 9 minus this, so it's going to keep going on. 61.33333. That's fine. What we really needed was that 61. Okay, so 3 goes into 84 61 times without going over. Okay, now we have a 3 here because we just bring that guy down. Let's do 3 times 61. 61 times 3 is 3 and then 18. So 3 times 61 is 183. We need one more to make 184. So there you go. That's the mixed number version of it. All right. So that was number 9. Let's look at 10. All right. So for 10, we have to do a common denominator. It's an addition problem, and we need a common denominator. What I want you to do is go ahead and pause the video now and see if you can do this one correctly, and then come back and we'll talk about it. Okay, so for 4 and 8, again, if you use your little multiplication chart here, you would see that their common denominator, you could multiply them together and get 32. But their least common denominator, again, if we do, let's see if I can hold this up, 4 and 8, and then 8, since 4 goes into 8, we can just leave it as that, okay? That means we're not going to be changing this guy here, but we are going to be doing 2 times 2. Again, if I do it on the bottom, I have to do it on the top. So we would get 6 over 8 plus 5 over 8 equals, we keep that 8 by itself. Now, again, I'm okay with you putting things in improper fraction form, but I'm not sure if your teacher is going to be okay with that. So how many times does 8 go into 11 without going over? 1 time. We have an 8 here. 8 times 1 is 8, and then 3 more will give us 11, right? Because we got to add there. We multiply here, add there. Good. So hopefully you got that one right. If you have any questions, let me know. Let's do number 11. All right, so I can't tell if this is division. I think it's a division problem. 9 divided by, I hope that first one wasn't division. I think that was plus. Okay. 9 divided by 4 and 2/3. Here's the deal with division with fractions. You can't do it. You cannot divide by fractions. You cannot divide fractions. What we do is we multiply by the reciprocal. And let's just do a little bit of side work here. The reciprocal is just flipping our fraction around. So the reciprocal of 2/3 would be 3 over 2. Okay? You may have heard this before as keep, change, flip. I hate saying that because once you get into algebra, it's a little bit different. But we're just going to talk about these reciprocals, right? Trick question, the reciprocal of 1 over 7 is 7, because remember, we can put anything over 1 and it's itself. That means like for 3, the reciprocal of 3 would be, put that over 1, 1/3. So again, just flip it around, make it into a fraction if you have to by putting it over 1, and that's what a reciprocal is. Now again, we can't deal with that until we have this in improper fraction form. So we're going to do 9 divided by 3 times 4 is 12, plus 2 is 14. 14/3. All right, so you may have heard keep, change, flip. Keep, change, flip. Or multiply by the reciprocal. Instead of division, we're going to multiply. And the reciprocal of 14 over 3 is 3 over 14. And just like those last multiplication problems, we can make this over 1. And multiplying fractions is easy because you just multiply straight across the top, straight across the bottom. So we get 27 on top and 14 on the bottom, 14 on the bottom. Now again, that's improper fraction. If your teacher wants to put it into mixed number, we need to know 14 goes into 27. Well, 14 times 2 is going to be 28, right? So we know that it's only going to go 1 time, and then 14 times 1 all the way up to 27 is going to be 13 more. So 14 times 1 is 14 plus 13 will give us 27. Hopefully that makes sense. Again, if any of this does not make sense, I've moved too fast, I've assumed you've known something and I'm wrong, let me know. Let me know if any of these are tricky for you. And I'd be happy to focus on those. So again, we got another division problem for 12. We have 4 and 1/6. divided by 3 2/5. I promise you I'm not sponsored by Coca-Cola, but I drink a lot of soda. It's dreadful. Side note, by the way, I live in Alaska. I don't know if your mom told you that. And it's a gloriously beautiful day here. I feel like I should show you my outside, but I don't know if I can move all my stuff around because it's all on my laptop. Like I said, I'm not technologically savvy. I leave that for the kids, right? So, show you my lovely neighborhood. It is a gloriously beautiful day outside, and that means it's only like 72 degrees, if that. I think it's probably like 68. Oh, see, I messed things up. I can't do it. I can't do it. Not allowed to do anything technologically advanced. All right, let's talk math, right? So again, we've got these guys here that we got to turn into improper fractions. 6 times 4 is 24, plus 1 more is 25 over 6, divided by 5 times 3 is 15, 16, 17, 17 over 5, 17 over 5. All right, we do the keep, change, flip, AKA multiply by the reciprocal. We can never divide fractions. We have to multiply by the reciprocal. And again, we flip that around. I am notorious for forgetting to flip. So if I make that mistake, definitely call me out. If I make a mistake with my tutoring students here, I give them chocolate. So let me know, and I will tell your mom she has to give me chocolate. All right, so we take a look at this guy now. We have 25 times 5. Without a calculator, think about it. If you have 5 quarters, you have $1.25. So it's 125. 6 times 17, we got to do the math here. We get 2, 4, and we get 102. 102. We will leave it at that. There's no point in putting that into a mixed number. It's just going to be a pain. All right, so that's how you divide fractions. You don't. You multiply by the reciprocal. So easy peasy. The next part of this page is combining like terms. Combining like terms. Now, there is a technical term for these things. I like to call them chunks. I'm sure there's a real technical term, but I have no idea. I'm the worst teacher ever. I have no idea. All right. A couple things here because we are going to be dealing with subtraction. Actually, it looks like we won't be dealing with that until the next one. We'll get to that. We'll talk about this. Okay, so we have 3 chunks here. Write this down. Chunks are broken up by addition and subtraction. Chunks are broken up by addition and subtraction. Also the equal sign, but we don't have any of those quite yet. So what we have are 3 chunks here. What I like to do is underline my chunks that I can combine. This has a little tag of an X, this has a tag of an X, this has a tag of an X. All of these guys can be combined. Now, I failed there. Notice that I'm underlining the operation that comes before. This is really important when we get to subtraction, and that's kind of what I was pausing on to look at the rest of these, is because that's going to be super important for us. So 3 and 7 is 10, plus 2 is going to give us 12. This is 12x. 12x. Let's look at number 2. Oh, that was number 1. I should probably say that. Number 2, 5x plus 2b plus 3x plus 5b is, okay, so now we have 4 chunks because they're broken up by addition subtraction. These chunks have different tags. We have one that has this X tag. And again, let's underline the operation that comes before it. This guy has the B tag. Can't combine them with my X's, so I'm going to double underline here. I'm going to tell you a hint. If you do things like this where you underline and you show what your brain is thinking, your teacher, if she's anything or he is anything like me, is more inclined to give you extra points, because if you make a mistake, but I can see what your brain is thinking, I'm not going to take away all the points, okay? So this is a really good habit to get into, and I'll be honest, after 15 years of teaching, I still underline my like terms, especially when I'm doing order of operations. Okay, so these guys we can combine. 5 and positive 3 is going to give us positive 8. 2 and 5 is going to give us positive 7. So 8x and 7b, that is your answer. Okay, so 3 plus 2x plus 4 plus 2x. Again, we have 4 terms here, or 4 chunks, right? Broken up by addition and subtraction, and we've got some that we can combine. This guy, this x, and this x can be combined. And then these guys are just like single lonely numbers out here, right? So when this happens, make sure that you combine the chunks with variables first. Those single lonely numbers that don't have variables, and again, a variable is just a letter that we use in math, those go at the end, okay? So we're gonna do these guys first. 2 and 2 is 4, so we got 4x plus 3 and 4 is 7. Bam, that is your answer. That is simplifying. And again, these things that we're working on are called expressions, not equations. Equations will have an equal sign. These are all just expressions, okay? It's really important you know the difference between those. Totally forgot where we were. Let's see. 4. 6y plus 5 minus y. All right, if you ever see a variable all by itself, there is actually a number in front of it. Again, mathematicians are lazy. We don't want to write things if we do not have to. So, but I am going to show you, there is a 1 in front of these guys, okay? So we have some variables here. We have 6y and we have minus 1y. Look at, I highlighted that, or I underlined that operation before it. That's super important. Then we got this lonely little 5. So 6 minus 1, we get 5y plus this lonely guy, 5. And that's your answer, okay? Let's look at number 5. 8a plus 4 minus 4a. Go ahead and pause the video and see if you can do this one on your own. All right, so let's see if we got it right. We've got a here, right? And then we got this a here. And notice I'm underlining that guy right there. And then we got these ones. So 8a minus 4a is going to give us 4a plus 4, plus that random 4, okay? Good work. Let's see about 6. Go ahead and pause the video and see if you can get this guy. It's the same idea. You just got to be real mindful of those signs, okay? All right, so we have this 4x, and then we have 15, and we have a negative 7 or a minus 7. Let's start with our variable. Again, you don't have to put it in the front, but it is nicer as you start to organize things. 15 minus 7, well, 7 and 7 is 14, so 7 and 8. So 15 minus 7 is 8. All right, let's look at this next one. We have 7. 6x plus 2 plus 3x plus 4. All right, we got 4 chunks here, right? We're gonna start with our variable chunks, and then we're gonna do our lovely little single ones like this. I probably should have had you pause and try this problem on your own. So 6, 7, 8. So we get 8x plus 4, 5, 6. 6x, that would be your answer. All right, so 2n plus 12 plus 3n minus 3. Again, go ahead and pause, see if you can do this one on your own. And when you come back, let's give it a shot. We're gonna do 2n and then plus 3n. We have plus, oops, I totally messed that up when I got really excited about lines. Let's try this guy. So we have 2n and 3n, we have 5n. 12 minus 3 is gonna give us 9. 12 minus 3 is gonna give us 9. All right, good. Last one. All right, so this one's tricky. We've got an operation that we need to do in here. We can't determine how many chunks there are until we do our distribution property. I call the distribution property the rainbow property because you take a rainbow from here and you arch it over to here, and then we're gonna take a rainbow and go here. So 3 times x is gonna give us 3x. 3 times positive 4 is gonna give us positive 12. I don't just automatically bring this sign down. You got to be real careful here because if you have a negative right here, you're going to throw things off. So you do positive 3 and positive 4 is positive 12 plus 2. Good. We have this guy that matches up, and then we have these right here. So we have 3x plus 14. 3x plus 14. Excellent work. That was all of page 1. If you have any questions, like I said, go ahead and give me give me a call. You don't have my number. Let your mom know, or just make a note here on the comments here, and I'd be happy to help you. Otherwise, I will do the other pages for you later this week. Hope that helped. Bye.